Okay, we're doing Spongebob 24, and we're dealing with inequalities, solving inequalities. And they solve much like equations. We have to isolate x with some certain differences. One of the main differences is that with equations, x can be solved to the left or to the right. It can be on either side, doesn't matter. With inequalities, we solve x to the left. So if x is not on the left, that's the first job, is to get it on the left side and then solve it from there. And the second thing is when we're multiplying or dividing by negatives, um, the signs change. Greater than is changed to less than, or less than is changed to greater than. Again, that's when multiplying or dividing by negatives. So those are the two major differences. X to the left and when you multiply or divide by negatives, change signs. Multiply, divide, then you have sign changes. Okay. So other than that, everything else is the same when you solve. So let's take a look at the first one. X is on the left, which is great. We're going to solve by subtracting 6 from both sides. So let's preserve the integrity of the original problem. So x plus 6 is less than 13. And then minus 6 from here. And we end up with x, this cancels, is less than, and this will be 4 plus 3 is 7. Okay. Now, this answer right here is set notation. It's the set notation answer. I want all three languages of answers for inequalities. So this is our first one, set notation. We'll also do the graph notation. So this will be open at 7. Put the 7 below. Let's put the 7 below. Open at 7, and this is less than, so we'll go to the left. Okay, so it's graphic. And the third one is the interval notation. Interval notation will be negative infinity to the left, 7, and close parenthesis. So I'm looking for all three of these answers for these. Okay, number 2, what happens when the x is on the right side and we want it on the left side? This little technique I'm going to show you is basically a kind of a cut and paste, or we're going to peel and paste. So we're going to peel the entire equation off the board, switch it over, and then paste it back. So this is what it will look like. When I pick it up and put it over to the side, this becomes x minus 4. This switches over to greater than, equal to, and then 13. And so basically I just put this side on this side, this side on this side. Just reversed everything. And now x is on the left. Now let's go ahead and solve for x. Add 4 to both sides. And I get x is greater than or equal to 17. Okay. And this is set notation answer. The graph of this would be closed dotted 17. Closed dotted 17 because of the equal sign. And since this is greater, we will go to the right. Now, interval notation would be bracket 17, comma, positive infinity. So, again, you need to answer this with all three notations. Okay, number 3. We're going to deal with the ideal of what happens when you have a negative on the x. Okay, and eventually we're going to have to multiply or divide by negatives on both sides. So let's see what happens with that. First, let's preserve the integrity of the original problem. And from here, I'm going to solve for x by subtracting 3 from both sides. And I will get negative x is greater than negative 14. So now I want to get rid of the negative from the x. So I'm going to divide both sides by negative 1. And because I'm multiplying or dividing by negatives, we'll get positive x. This sign changes to a less than, and this becomes positive 14. So x is less than 14. The graph of that will be an open circle at 14 and going less than, so to the left here. Furthermore, the interval notation for this will be parentheses negative infinity to 14 and then open parentheses. So those will be three ways of answering this. Okay, on number 4, we have two problems. We have negative on the x's and the x's on the left side. So we're going to flip that entire problem just to get the x on the left side. Sorry, the x is on the right side. We're going to flip that to the left side. So let's switch everything. So this will become negative 13 minus x. And this changes to less than. We flip it, and negative 24. Okay, and now x is here on the left side. Now let's start solving for x. We're going to get rid of the negative 13 by adding 13 to both sides. We end up with negative x is less than or equal to, let's see, this would be negative 11, I believe. Yeah, good. Okay, now we want to get rid of the negative from the x, so we're going to divide by negative 1 on both sides. And what that will give us is x here, positive x, and we're going to sign change. So instead of less than, we switch over to a greater than or equal to. And negative divided by negative will be positive 11. So the set notation for this is x is greater than or equal to 11. The graph of this will be a closed circle about 11 on the number line. And since this is greater, this will go to the right. Okay. Now the interval notation for this will be a bracket at 11 and then positive infinity on the right side. And that's how you get all three types of solutions or notations for the answer. Okay, let's see, number 5 and 6. That's not it. Using just regular alcohol. Okay, the board. And let's see, 5 and 6. So 5 is going to be 10 minus x is less than or greater than or equal to negative 13. And 6 is negative 14 is less than negative x minus 2. Okay, here x is on the left side, which is good. We're going to get rid of the 10 here. So preserving the integrity of the original problem, I'm going to write 10 minus x less than or equal to negative 13. Okay. And these, again, when I preserve the original problem, the integrity of the original problem, that's what I look for when I grade whether you're copying down the problems exactly as I do. So if you see reductions of your grade, it's because you're probably not writing this down twice. Okay. Or one of the reasons. Okay, so let's subtract 10 from both sides. And we end up with negative x is greater than or equal to negative 23. Okay. All right, from here, I'm going to divide both sides by negative 1. This will end up giving me a positive x. This will change from a greater than sign to a less than or equal to sign. And negative divided by negative will be positive 23. All right, furthermore, the graph of this will be a closed circle about 23, and this will go to the left. It's less than. And the interval notation for this will be negative, parentheses, negative infinity to 23 and a bracket. So those are your three notations. Okay. Number 6. We see that x is on the right side, so we're going to fix that. We're going to flip everything over. So this becomes negative x minus 10. This sign switches to greater than, and then negative 14. Okay. Now that x is on the left side, I'll begin to solve. I'll start by adding 10 to both sides. That gives me negative x is greater than negative 4. Okay, good. Okay, we're going to divide by negative 1 in order to get rid of the negative here. So negative 1 here, negative 1 here. And I end up with x switches to less than sign and positive 4. So x is less than 4 is our solution. The graph of that will be an open circle at 4, and less than takes me to the left. So all the numbers to the left of 4. Furthermore, the integral notation for this will be parentheses negative infinity to 4, and that'll be parentheses because 4 is not included in the solution.